welcome everyone again. My name is Georgi. I'm an engineering manager here at DFINITY. And today I'll be your host. This is September 25th, in case you didn't know, 2024. I just woke up from hibernation or something. So agenda today, metrics first with Kyle, as always. Will be probably, I'm pretty sure he has prepared something interesting for us. That will follow up, I'll continue with ecosystem updates from Bjorn Takman. And then last minute token 2049 update from Emilio. Let's see if he added his slides. Yes, this is all live. And then we'll move to demos, a few cool demos. Motoko try finally. When I was first reading this and I was, oh, Motoko finally made it to a demo, but no, it's try finally construct in Motoko. So we'll hear from Gabor and Eduardo and about security best practices. And later we'll continue with performance-based node provider rewards from Pietro, and Neutrinite is also here to do a demo. So Kyle, do you want to start today?
Sure, love to. Thank you, Georgi. Yeah, so last time I presented at Global R&D, I presented on cycles burn, and I thought maybe I could be done with that for a couple weeks or even hopefully a few months. But then maybe a week after that, Bob.Fun launched and requires me to now talk about cycles again. So here you see a pie chart of September or a donut chart of cycle burn and what's caused it. So you can see in September, a little about 70% of cycle burn has been from Bob.Fund. Burn also contributed. They have about 24%, let's say. And then you can see everything else on ICP is about 5%. One of the things I want to use my time here to drive home is kudos to Bob and to Burn. Awesome products that are really finding great adoption. I love seeing that. What I don't want people to miss, though, is that is not the only cycle burn growth on ICP. So if you go to the next chart, this is going to be a daily cycle burn for ICP, excluding Bob.Fun and burn subnets, right? So these are all the other subnets. And I just want to point out, this is going all the way back to 2022. You can see all the way on the right there, just a nice vertical growth chart. So I've been presenting throughout the summer. We've been seeing significant cycle burn growth going into the summer and throughout the summer. Summers tend to be more slower months for ICP and for crypto as a whole in terms of like network activity. But we saw a lot of growth there. I anticipated that when we got out of summer, we would actually see a nice uptake, because the slower summer months, maybe even though we were growing during the slower summer months, we probably can grow even further when it's not summer months. And you actually see that playing out in September already. If we go to the next chart, it's the same data, but presented as a bar chart just to give scale. So you can see September is, I think, 111% greater cycle burn than we had just in August. So August was already like 50% greater than May, and now we've doubled that since then. And this, again, is excluding the subnets that are running Bob.Fun and burn. So this is extremely positive data. And then if we go to the next slide. Just to drive it all home, the point of burning ICP is to get cycles, and then you see those cycles being burned. As of this data is as of yesterday. You can see 129,000 ICPs been burned in September so far. To put that in perspective, we've had 358K minted for node provider rewards and 950 for governance rewards. I would anticipate, just when you look at how this data breaks out, I'm anticipating that in October will probably be the first time in ICP's history where we have a month in which the ICP burned is greater than the node reward, the ICP minted for node reward. So I'll keep an eye on that. Maybe early November, I'll jump back on and see if that prediction is true. So if you have any questions, feel free to put them in the chat, and that's my time.
Thanks, Kyle. Looks like we're going to talk about cycles again next time. Quite insightful. All right, and let's continue with ecosystem updates from Bjorn Takman.
Yeah, quick disclaimer. I'm going to present a very small selection of noteworthy events this last week. If I'm not covering your favorite event, I'm sorry, please don't be mad. So please, Georgi, next slide. The first one I think is an absolute must-have. Omnity bridges CK-BTC to Cosmos through osmosis. Let's unpack that a bit. Cosmos is one of the older blockchain ecosystems. It's an entire ecosystem of chains that are connected through a protocol called the inter-blockchain communication protocol. Osmosis is one chain and a major DEX in the Cosmos ecosystem. And so Omnity, one major project building on ICP, is now using chain fusion technology to bridge CK-BTC over to Osmosis. Now, this is fantastic, of course, for ICP. It's a great use case for chain fusion technology, but it's also great for the Cosmos ecosystem, because right now the main representation of Bitcoin they have is WBTC, which, if you followed the crypto news, it has gotten a bit of criticism over the last couple of weeks due to business deals between BitGo and Justin Sun and so forth. So now they actually do have a non-custodial version of Bitcoin available for trading on Osmosis, and thereby available in the Cosmos ecosystem, which is a fantastic chain fusion collaboration news. And it has been covered widely in the crypto media, so I've put some links here. Next slide. This is news from one of our SNSs, which is the Motoko SNS. Motoko is not only the logo of the Motoko programming language, it is also the theme of two NFT collections that were airdropped in the last couple of years: the Motoko Ghosts, which look like the one you see here on the slide, and the Motoko Mechs, which look kind of differently. And so the Motoko NFT canisters were created and are since then escrowed by Tonic Labs. Now, a bit later, the Motoko token was created. It was airdropped to holders of the Motoko Ghost NFTs. And then this token was basically turned into the token of an SNS DAO. And that's where we are today. We have an SNS DAO that has the Motoko token. And now in proposal 39, this Motoko DAO stated its intent to take over the control of the NFT canisters, so that fundamentally they achieve the goal of putting the canisters under the control of the community that is holding these NFTs. Next slide. My last one for today is about Neutrinite. Neutrinite, another SNS DAO on ICP, has decided to diversify their DAO treasury. So Neutrinite is a DAO that provides essential and pretty great DeFi tooling to the ICP ecosystem. One of the main user-facing tools is icpcoins.com. If you haven't seen it, visit it. It's well worth a visit. It's like a coin market cap just for the ICP ecosystem. Neutrinite has had a decentralization swap in December 2023, which brought in 225,000 ICP. And so last week they decided to diversify the treasury by swapping 6.4 thousand ICP into DKP, the governance token of the Dragons DAO, and 1,000 ICP into NICP, the liquid staking version of ICP created by the Water Neuron DAO. So fantastic cross-DAO collaboration here. And as a final great theme here, this uses Neutrinite's DeFi vectors, which are going to be presented in the community demo today. So I'm really looking forward to that. And it's going to give you much more detail on what happened here behind the scenes. Back to Georgi.
Thanks a lot. What a coincidence, huh? We have a demo from Neutrinite later today. All right, and if you don't know what token 2049 is, then now we are going to learn from Emilio.
I will be presenting it on Team's behalf. Clement here, just for the intro community programs lead at adoption team, and I will present. So ICP token 2049, September 17th to 20th. Why? So the why section of this question starts with Singapore and the importance of token in the region. So while it's a very significant annual event, we realized at some point that official participation and sponsorship is not very viable from the ROI perspective. So and we don't get quality and quantity of engagements that we think ICP and Chain Fusion deserves in such periods. So then we came up with an alternative approach. where we put together the resources and partners together to create some common space for everyone to run their own activities, engage with communities, and that being the hub of interoperability conversations happening during the Token 2049. So that is quickly about why. How, really briefly, a few points here. We established Chain Fusion narrative by integrating really strong partners from Ethereum communities, Bitcoin community, Cosmos community, but Osmosis, and others. We provided them the open platform for organizing and curating their own agendas and bringing in their own speakers and guests, but all of that happening under the umbrella of Chain Fusion Hub. Us taking care of what really helped out thing here, and what we piloted in Brussels and polished to another level here is that we took care of the scarce resources such as time and location. In this equation, what we learned is that securing a premier location really helps us with onboarding really good speakers and really good partners. So that's what's been done ahead of the time. So then when partners realize 30 days in before the event that they would like to do something, we were that launch pad for them to make those tough things happen. Yeah, so in the essence, I'll just summarize the rest. In the essence is for us to provide an open platform and then open the conversation and establish touch points with multiple ecosystems at scale on our terms, on our ground, basically. Moving on. So what did we get in result? We got 7+ ecosystems. There were guys from Bitcoin, Ethereum, Aptos, Cosmos, Ripple, Stellar, and Solana coming into the Chain Fusion Hub for one reason or another. We plugged in external stakeholders. Yeah, the partners that helped us really communicate and engage into the narratives that are currently relevant for ICP. So you see that Cambodia Ministry of Science and Technology came in as a part of the bigger collaboration that cross teams are leading with UNDP, and there's the Dubai Department of Economy and Tourism, and so on and so forth. One-time guys are really influential in Asia, and all these folks were we created an experience for them, basically. To give you a look and feel of what it was like, this is the venue that I was talking about, the Fullerton Hotel. It's earned the reputation of the place for meetings, for where the business happens in Singapore, so to say. It was right in the heart of F1 track, just for the people that are into that. So that was building up additional level of excitement because Formula One cars could have been seen around the venue itself. This is how it looked like, but more of so is just to give you the scale of what's been going on there, that we had particular zones, right? There were like 3 main stages, ballrooms. There was booth area with 15 stations for ICP projects and so on that we'll talk about in a bit. There's photo booth, podcast station, live pitching station, media room for meetings with journalists, interviews, and all that beauty. And of course, we needed to have tangible goals, objectives here, and KPIs. So you see that this is the version pre-event, and I'll show you in a second the actual numbers, what we've achieved. So we were shooting for 1,000+ people attending, not signing up, but attending in the course of 2 days. At least 2 major announcements, provide pitching and speaking opportunities to 20+ ecosystem projects. It's worth to notice that it was really a great piece of collaboration with the Grow team. I absolutely enjoyed it because we managed to cover the grounds for 30 projects, ICP projects that are coming down to token. So we would match what kind of engagement can they get on this platform? Are they presenting at the booth? Are they speaking? If they're speaking, what is the most relevant for them? So that was a massive work, and very happy for the collaboration that was there. So some projects would get exposed on purpose to the KOL, so they build up their traffic sources. Some of the KOL, some of the projects that we knew that are raising, we would help them and facilitate in the best way possible we could to get exposure to VCs, and it played out quite well. So while all this data is very tangible, it can be seen offline. We can share the link. So we'll just move more into the nuts and bolts of this. So in the end, we got 7 ecosystems, 13 projects, 100+ project pitches that we facilitated throughout 2 days from different ecosystems, but ICP being the core. 150 speakers joining us, 400 vetted and verified KOLs were in the house, 2,000 check-ins. So we kind of overshot the attendance by 2. We got 2,000 plus more than we. So this is the data on Twitter, how much time, how much the Chain Fusion term was mentioned. And let's dive into the events themselves, what we ran when we say 13, right? So the headliners, we had a few, right? Chain Fusion Day was definitely one of them. So we had 4,000 signups that we were shooting for 20% conversion, actually, given the size of the side events during the token. We got 100+ attendees, 17 speakers, Lamesh, Sunny, Agarwal from Osmosis, Lilo, Vinit. So you see password there, Shashi, and so on. So that was good. You see that it was very well packed nicely. The layout was great, and we got a lot of content out of it. Next headliner, there was more focused on Ethereum community on day 1, September 19th. We hosted Ethereum Pragma, Singapore at our premises. They took one of the ballrooms, and that helped us to bring in 300+ hardcore ETH maxis and top speakers, right? So Dom had a fireside chat with Kartik, which was very nicely met. And then Stanik Kulichov was there, Sandy, Sergey, Sandeep, all the usual suspects were there, and that is quite of a nice, one of the nice touches of the Chain Fusion Hub in Singapore. Then it wouldn't be Chain Fusion at all if there is no Bitcoin, because our core theme was that we bring this 3. The entire experience was created around 3 assets: ICP, Bitcoin, and Ethereum. So on second day, September 20th, we had Bitcoin events, quite a few of them, 4 to be specific, 4K signups in total. So why it's important, because it's a data point of touch points that we established with 4,000, 5,000 people during this time. Casey Rodemore was one of the speakers of one of the events. Joy Soon from Magic Eden, Satoshi Protocol, DFINITY Foundation, BitLayer, all those kind of folks. Really run through into our another nicely curated experiences was Olympus Founders Brunch. Since it was well received, the Founders Breakfast was well received at ECC, right? And then Olympus Brunches were well received there. We kind of decided to merge it, and it went pretty well. We got 800 signups, 30 projects was going off the stage, giving elevator pitches every minute. Was pretty nice energy there. If you think that that's a lot, we just getting started. There was also a KOL gathering with 400 pre-vetted influencers. That's what we mentioned already. As you see from the branding, it was done in a collab with Cointelegraph Accelerator, but they're part of Cointelegraph group, so that's okay. That gave us pretty good traffic, to be honest. Inflow traffic, people were showing up and stacking up in lines. There was a really pleasant scene to see. Quickly moving on to another activity that we ran for the first time. There was a Killer Whales live edition of at Singapore at Chain Fusion Hub. So what it means is basically an attempt for Shark Tank, but for Web3. There are currently only 2 shows in the market of this sort. This is basically the pioneer, and as you see, they brought in us as the judges. We had Pierre, we had Mario, we had Gracie, and Yev. So we had nice lineup of Nawal. Nawal, basically, this marks the first event where Nawal ever stops by, and right from the beginning, he opened up saying that I'm a huge fan of ICP. I think it's undervalued, and that's all in the recording. So that is a good touch and platform that we managed to pull off. Part of this was also the pitching booth. As you see here on the right corner, we were inviting people to pitch in person to shortlist themselves for this third season. And that generated good traffic and exposure for these 4 projects that you see: DFINITY, Metapool, the Expanse, and Piggy's Hub. Jumping into yet another hot one, VC Startup Connect on a day 2, when we thought we couldn't get even more crowded. This definitely broke the roof, and we started seeing people checking in way ahead of the line. That was good, which also generated 4 pitching opportunities for ICT projects to externals. So to not turn this segment into 2 hours call, we just listed here another ones that also happened in the NTR, Chain Invasion Malaysia. Of course, there was Chain Fusion Night as a sequel of Chain Fusion Day, and it all was nice. But really 2 things that we wanted to mention that are also new. We had a podcast station this time around, so you can see that from the scale of this operation, it sort of turned into the conference arrangement without feeling like one. We received a lot of nice feedbacks because people were mingling from the communities and circles that they would usually not see each other. We collected 100 applications of this sort. 60 cross-chain pitches were recorded. So what was the point here is that get your project seen by millions. And this way we are pushing the narrative that if you're a cross-chain project, multi-chain or interop project, right, and then you have something to do with Chain Fusion, you can also get a nice boost in traffic and reach into KOL. So this is a sweet little angle that we found, and also it was well received. Booth. This time around, we also had a proper booth arrangement for our projects and partners. Of course, there was a big one for Chain Fusion, where thanks to all the team that participated in that section, because there was a lot of conversations going. You can tell that from the gas flow perspective, all the 2,000 people that went through the venue, through the event, they were forced to go through this booth area. So that gave us pretty good eyeballs there. And get into the cherry on top is like announcements. As you remember from the initial KPIs, we were shooting for 2 announcements, general announcements to be done during the Chain Fusion Hub. This is one of them, just to mention and wrap it up, because it's a strong chord kind of to play here. So there was PR going on around Cosmos integration. Sani was there, his team were there. We shot nice interviews with them. So did what we could together with the team to get the most out of it. And in the end, we realized it, although that was not the goal or on the KPI, that was the biggest ICP event till date, according to some metrics, right? If you have data to prove otherwise, please let us know.
All right, moving on. Thank you a lot. Thanks a lot. And we'll continue with Motoko try and finally demo. And that would be Gabor. Gabor, are you ready to take over?
So good afternoon and welcome. I'm Gabor, a senior software engineer on DFINITY's languages team. Please let me introduce you to Motoko's new try finally feature. So we are striving to make Motoko, the Motoko language, not only easy to use, but also equally secure to use. So we were on the lookout for a language mechanism to deal with resource deallocations in a structured and disciplined way. Out came that we adopted the well-known syntax of try, catch, finally for Motoko, following the practice of Java, Python, and C#. In the process, we adapted its semantics to the specific case of the Internet Computer runtime environment. The result is also aesthetically pleasing, especially when compared to the drop trade mechanism that the Rust CDK employs, which, by the way, is an example of the resource allocation is initialization pattern. Adding a finally clause to the already existing try block is a neat way to guarantee that user-defined cleanups of temporary changes, such as logs, happen in a specific highlighted location, since all execution paths, including after return, break, continue, and also after throw from the catch clause, are now uniformly routed through the finally clause when present. Additionally, and this is unique to the internet computer, when message result processing encounters a trap, all outstanding finally clauses in the current call chain are run to avoid any dangling locks or similar. This is a special feature of the internet computer and necessitated due to its state rollback to the latest commit point when a trap occurs. We'll hear more about this from Eduard later after my demo. That said, finally clauses have checked restrictions and as such can neither send messages nor branch out via break or return. Trapping in them will still abort and roll back cleanups, so you should be very sure to review your portion of code thoroughly. As an additional bonus, when the finally clause is present, the catch clause becomes non-mandatory and exceptions are simply propagated to the next enclosing catch. I am happy to report that the feature is already available in the latest beta of DFX. So I think I have already deployed, but let's deploy again. Okay, so in the meantime, I can say something to the code. I have concocted this up as a single actor. The main function is this demo function, and it tries to log as it goes. And the main point is this try construct, which now has a finally part. So we can catch exceptions that happen inside of this try block and clean up stuff with the finally. Good. The input is a condition, which can be some scenario that should be demonstrated. So the easiest one is, of course, the happy path, where it just goes straight through, calling out. In this case, I call an internal method, but it could be an external method too. Doesn't really matter. So let's run that. Then I have a query function here to show the current log, which gets reset every time on entering. And it's basically a poor man's logging facility of a global variable with a log function that just appends new stuff at the end. So let's see what comes out there. And as we can see, we enter a function, then the cleanup runs because nothing unusual happened after the out call. And finally, we leave the function the normal way. Okay, good. Let's try something more interesting. Let's trap internally. That will be this assert here, which happens after an out call. So this is the very problematic case where earlier we couldn't really recover from this. Now we can. Let's call it. Okay, and what is the log? The log shows that we have been entering the function, but never left. Yeah, but anyway, the cleanup was running for trap intern. So this shows that if you allocate any resources here in the start, you will be able to clean up still, even if there is a trap happening. We didn't leave the function here. And why are we seeing entering at all? Don't we have some rollback mechanism? Actually not. Actually, we have a rollback mechanism, but in this case, we have a commit point at this line. So awaiting for a call commits the previous state changes, and that's why we see the entering. Okay, So how does it look when I say, let's trap externally? That would be in this position. So that is basically a result that will be caught here. Let's see if that happens. We called it. Let's get the log. It says entering. We caught a canister error here because of this trap. And then we still run the cleanup and finally leave normally. Okay. These were the interesting cases, basically. Throw is very similar. So let's have a look at break. Run the break. In this case, we have the call and break out of the try to this label, which brings us to the end of the expression. And then we expect, of course, leaving. Let's get the log. And it says we enter, we have the cleanup running, and finally we leave. I will spare you from showing throw because that's totally equal, very similar to the trap extern. So that concludes my demo, and I hand over to Eduard. Thank you very much.
Hi, I'm Edward from Product Security, and today I'm here to show how one can leverage the feature that Gabor just presented from a security perspective. Just a heads up, all the information that I'll present today is well documented in our security best practices. You can find the link in the QR code. Next slide. Yeah, so a quick refresher on how message execution works in the IC. So Canister implements methods that can be called via update or query calls, and messages are a set of consecutive instructions that a subnet executes for a canister. Whenever a call to a method is made, this one can be split in one or more messages. For example, if inter-canister calls are made in an update call, this one will be split in several messages. We can see that behavior here in the code example. So here we have an update call implemented in Motoko, and in this case, since we have an inter-canister call, the call will be split in two messages. The first message in the orange box will execute from the start of a function until the inter-canister call is made. And then the second message, what we refer as callback, marked in a blue box, will execute the rest of the lines. A single message is processed at a time per canister, and messages from interleaving calls have no reliable execution ordering, meaning that in this code example, if two calls are made roughly at the same time, there can be different message orderings. And we can see that in the illustration. For example, on the left, the messages of the first call are scheduled first, and the message of the second call are scheduled last. This is the intuitive ordering if you see the code, but actually there are other possible message ordering. For instance, in the right, we have another message ordering where the first messages of each call are executed first, and then the second message are executed last. Next slide. Yes, and this brings us to the security concern that I want to talk about today, which is that since there is no reliable execution ordering of messages from interleaving calls, the state of the canister might change between the time an inter-canister call is started and the time when it returns. This is known as reentrancy bugs, and sorry, the impact these bugs have will depend on what's being done in that function. For example, an attacker could abuse it to exploit the double spending issues, like getting several refunds or make several transfers without having enough balance. To address these issues, one normally uses the locking mechanism. And for example, in this code snippet, we have an implementation of a simple lock. We use the Boolean variable to check if a call is being executed, meaning that all the messages are being executed. And if so, the function is locked. So it won't get executed by other callers. The lock is released in the callback normally, but that bears the risk that the lock might never be released if the callback traps. So in this example, if the update some statistic function traps, the message in the blue box will not get executed, and therefore we will be locked forever. In Rust, it's possible to solve this using the drop pattern, and in Motoko, it was not possible before the try finally statement feature, but now we have it, so let's see how can we achieve that. Next slide. Yeah, so in this example, we have the same block pattern as in the previous example, but we use the try finally statement. So in the try statement, we check if the function is locked, and we return an error if it's locked. Otherwise, we acquire the lock, and then we execute the rest of the code as normally. There we can do inter-canister calls or calls to other functions. And then in the finally statement, we release the lock. So even as Gabor mentioned, even if we trap during the try statement, we will execute the finally statement and the lock will be released correctly. This is just a really simple example, but one can adapt it to other users' case. For instance, having a lock per color instead of a global lock. It's really important to, as Gabor also mentioned, to not trap in the final statement, because we can end in a non-recoverable state. And yeah, and that's mostly it from my side. So just a quick reminder that you have all this information in the security best practices. And yeah, that's it. Thanks for listening.
Thanks a lot, Eduard, and also Gabor for the feature. There was quite some excitement in the chat. Please take a look and answer any remaining questions there. Let's continue with Pietro and performance-based node provider rewards.
Thanks, Georgi. So I'm Pietro. I'm part of the DRE team here at DFINITY. Today, I'm going to talk about performance-based node provider rewards. And currently, node providers are rewarded independently from their node performances. And we want to propose a change on the rewarding system for the node providers. We think, in fact, that reward should reflect actual node contribution to the protocol. And also the node provider should be accountable and incentivized for maintaining the good health of their nodes. We also want to differentiate between the nodes which are doing active work, meaning are assigned to some subnets, and the ones that are instead unassigned, which probably should be rewarded differently. So how we want to do it is using trustworthy node metrics coming directly from the subnets to assess the node performance, and adjusting reward based on this assessment. And in case of underperforming nodes, apply a reduction on their rewards. We have involved, and we also want to keep involving node providers and the entire ICP community in the decision-making process for the design of the rewarding algorithm, but also for its tuning. Next slide, please. Yeah, let's give a bit of a background on the trustworthy node metrics. In each protocol round, a node is basically selected to be a block maker. And for a node to successfully make a block, it must have good properties, like it must have a robust network connectivity, adequate compute power, and storage resources. So the idea behind the rewarding algorithm is that counting the number of blocks a node was tasked to make and compare this number with how many blocks it successfully made provides a reliable indicator of a node contribution and node performance and contribution to the protocol. So the subnet exposes these node metrics daily. So for each node, we can get how many blocks it proposed and how many blocks he failed to propose. And the tool I'm going to demo today allows you to export these daily node metrics, visualize them, and also understand how they are used to compute node rewards. Next slide, please. Yeah, so let me share my screen. So yeah, this is the tool. What you see here is a React application inside a front-end canister, which interact with a back-end canister written in Rust. From the node list, we can select the specific node, but also you can filter by the different attributes displayed in the table. For now, for the example, we just select one node that I know has some reduction for at least the last reward period. From this link, you can access the node machine page. At the top, some node information. As well, you have the node provider ID owning the node. And on the section below here, you find the last reward metrics. So the last reward period was between the 14th of August and the 13th of September. And here, for each day, you see the amount of proposed blocks by the node and the amount of blocks which the node failed to propose. So as you can see, in the last days, the number of failed blocks increased quite substantially with respect to before. And how the rewarding algorithm works in this case is summing up the proposed block first, and you get this number. And then the algorithm sums up the number of failed blocks in the period, getting this other number. Now from here, what we want to do is to compute the failure rate for the node machine. This is done by basically doing the ratio between the blocks failed and the total amount of block that the node is tasked to make, meaning the sum of the failed and the proposed. And we get this final failure rate, 30%. This number is basically rounded, but this rounding happens just in the front end. In the actual canister backend, no rounding is applied, and decimal precision number are used in the entire computation. So no round is expected by the node provider when he gets the reward. But coming back to the example, we get a failure rate of 30%, which falls between this range of from 10% and 60%, in which we apply linear reward reduction. For failure rates below 10%, we don't apply any reward reduction. And for failure rates above 60%, we have kept the reward reduction at 80%, meaning whatever performance we get out of a node, for the moment, node provider should expect at least 20% of the rewards for the machine. So these numbers, by the way, are completely tunable and are not set in stones, and that's why it's important the contribution of the node provider and from the community in general on how to make decision on how to set this number and where to do it. So for a failure rate of 30%, we get in this case a reward reduction of 32%. So from the full reward, meaning 100%, we reduce 32% of rewards, meaning we get to a reward multiplier of 68%. This number will be multiplied when computing rewards by the base monthly reward in XDR, which is the full XDR rewards for the node machine. And once we do this for all the machine for the node provider, then the numbers can be aggregated and the final grand total of rewards for the node provider can be computed. So down here you find a simple explanation of the algorithm, and also even further below you find the possibility of expanding using the date range and to export from this table the metrics I mentioned before, so the blocks proposed and blocks failed for the node, and do the same computation on your own if you want. So from the same page, you can also access the node provider page. This is displaying just information about the node machine owned by the node provider. And also for the moment, the last rewards that the node provider received in the last reward period. We want to add in the near future also the expected reward with the reduction to easily compare with the current one and to see the difference. Down below, in this chart, you can see you can expand it over multiple days, and you see basically the top 3 nodes with the highest average failure rate in the period. This is used if you want to explore more the nodes over here and dig in deeper. And the node provider can also export metrics of the blocks failed and block proposed for all of the node provider nodes. So you have the possibility also to filter by the different node providers using this drop down on the left if you have the node provider ID. So coming back to the presentation, the tool is already available on this link for you to use. We actually encourage you to do it. Also you can find the source code, which is open source, in the DRE repo for both the backend and front-end canister in this link down below. And this is a possible future architecture, how we envision the canister being a part of the NNS in the future. In particular, when the governance canister needs to mint the rewards for the node provider, it needs to have a mapping between a node provider ID and total XDR amount, it can get this mapping directly from the node provider rewards canister, and this canister contains all the logic and perform all the computation for the rewards of the node providers. But to do it, it needs to interact with the registry canister. It needs to get the metadata for the node, in fact, the node ID mapping to the node provider ID, and also a node rewards table, which contain information about the full reward to be given at each node machine. It also needs to evaluate the performance of each node for the algorithm to work, and that's why it needs to basically query each subnet, and this is done daily. This is the next steps. Currently, we are in the phase 1. Will last 2 or 3 months. So in the first phase, we want to make stakeholders familiar with the methodology and the data, collect feedback from node provider and the entire ICP ecosystem about the rewarding algorithm, and add more data to the tool. As I mentioned before, we want to add the expected reward with the new methodology to compare them against the current rewards, and also to display directly from the dashboard the entire computation that we perform in the canister. One important thing to mention is that during this phase, nodes reward will not yet be impacted, and for the moment, it still need to be defined how do we handle and how do we reward the nodes which are unassigned. After phase 1, will come phase 2, where we're going to implement automatic adjustment of rewards based on the node performance, and we are going to integrate the node provider reward canister with the ICP protocol.
Thank you very much, Pietro. And I think that the tool that you shared will be the next favorite tool for all node providers. Last but not least, demo from the Neutrinite team.
Good day. I'm Veselin Tsukiev, founder of Neutrinite, and I'll be presenting you DeFi vectors. let's start with an idea. Perhaps somebody wants to dollar cost average BTC into ICP and then split it, some of it sent to an ICP neuron and then use the maturity to exchange back to BTC. And the other part change to an ICP and send to a lending protocol and then use the fee in some way. Now they can do that with dApps and manually, but when we need it to be a part of a DAO, the DAO can't do it unless it's a smart contract. And the problem with that is smart contracts are quite complicated. They have to connect to various canisters to obtain data, like the exchange rate canister, which is fine, but the swap canisters have custom interfaces, custom data, and then using that information to execute the logic by contacting, again, DeFi canisters with custom interfaces. And everything is async, so it requires time and expertise to create something like that. Let's zoom on just this part of it. Like currently, the swap canister is obtaining the current rate from the swap client is obtaining the current rate from the swap canister, and it's sending the tokens, and then after that, it's sending an instruction to swap using the rate it just got. And if we zoom deeper on that, we have the client first sending tokens to the ledger, waiting for a response, and then contacting the DeFi canister, notifying it by depositing the tokens. The DeFi canister goes to the ledger, takes the tokens, and then the front end again calls the DeFi canister to swap. And then we draw, again, we go back to the ledger and we draw the tokens out. It's quite a lot of steps. All of them are synchronous. Some of them are crossing boundary nodes in this case. So how we're solving the problem is with various standards and protocols, working on that in the DeFi working group. And some of them are dealing with the data, like ICRC 45 and 47, and some of them with the execution of the contracts, ICRC 55. So what is ICRC 55 doing? We have a DeFi client. Instead of sending the tokens and then instructions, we are sending the instructions first and creating something like a smart contract inside the swap canister or DeFi canister. It essentially has source address that points to a destination address and has parameters, in this case, the 1% slippage. So once this is created, we can send to the destination address we received continuously and reuse it, swapping more and more tokens. And the way the DeFi canister now works is it just follows the ledger using ICRC3, and then it decides what to do and sends transactions to the ledger. We've made a framework, a middleware library where these are handled, and the developers just code synchronous logic. And there are benefits on composability, because once we create our vectors with ICRC 55, we can just send tokens after that, and they are passing their tokens to each other, which wouldn't be possible if we wanted them to pass also instructions, because every canister would have to know the interfaces of every canister ahead. So this is the exchange vector. It could be visualized like that. We accept ICP, and then the output is NTN. There is also an algorithm which is adjustable. And this is currently the front end we have. The contracts are audited by 2 independent auditors, and it's DAO governed by Neutrinite. The DAO is currently using it to obtain CK-BTC and ICP and DKP, and swaps are happening every 10 minutes automatically based on an algorithm. Everybody can create a vector, and these are the parameters currently. It uses, when it comes to the ICP CK-BTC pair, it uses the HRC canister, and the default settings are 1% above the current rate from the HRC. And there is also a maximum per second that can be adjusted, and a maximum rate. So we can execute dollar cost averaging. Now we can also chain these by setting the destination of one to be a source of another. And what happens inside the canister is shown with green lines. We have one owner who has deployed an exchange, and owner 2 that has deployed an opposite side exchange. And it's visible here what actually happens with the tokens. They're going from the source of one to the destination of another. And also the developers need just code that synchronously. They don't need to deal with the synchronicity. You can also have an IMM where the destination of one is the source of another, and the opposite way around. And then when somebody comes to, for example, buy NTN for ICP, this is what happens. The AMM is going to end up with a lot of ICP, but then somebody else comes and trades the other way around. So now it rebalances. So we have standalone sync nodes like throttle, split, escrow, event, which are not working with other nodes in the same canister. They're just splitting the tokens or throttling them like this here. These are all configurable. And we also have service-oriented async nodes like the NNS, Chain Fusion, DEX, and every DeFi service in the world can be vectorized. Even Uniswap and Fusion, chain key cryptography. This is the Neuron async service. Basically, the developers have somehow made it work by spawning new neurons and extracting the maturity, but the user doesn't need to know about that. And there is collaborative async node, exchange, lending, borrowing. I've showed the exchange. I'll show you quickly the borrowing part. So one user is lending NTN in this case, and another one is borrowing by providing ICP collateral. Whenever they provide collateral, the green again shows what happens inside the canister. When everything works as expected, it's collecting fee, lending, and if the price drops below a certain point, there is liquidation. And there is also a possibility for repayment. It's just a mix of like inputs and outputs. So we can also connect these to the exchange vector. And in this case, we are longing ICP with leverage, depending on the parameters, because once we provide collateral and borrow NTN, it's swapped back for ICP and provided again as collateral and again. So it changes the leverage. And depending on how the pairs are, you could long one and short another token. So we have started working on a builder. This part is still in development. And the user, which we call an architect, selects Pylon, which is a canister that has these DeFi contracts. And inside it, there is a marketplace with different types of smart contracts, which vectors. We're going to deploy one. For that, there is a custom form. Now, we haven't gotten rid of the customization like every canister, every smart contract needs to have something custom. But instead of having the custom parts being part of the flow where contracts are communicating, they are just communicating with transfers where the custom part is handled by a human or AI who creates or modifies using the custom form. So we are going to deploy an exchange canister, an exchange vector, and then another one, and we can connect them. And with that, build something pretty complicated. The builder is actually working with ICRC 55 only to connect to a Pylon canister. We would call it the Pylon part of the other protocol. And it's the only way to communicate with it, with ICRC 55, allowing users to deploy these designs inside. So at the end, we have a lot of users and their smart contracts are communicating. We are working on the protocol and also on a Motoko framework that makes it pretty easy, and it's almost there currently. Recently, we added a new feature that instead of getting every transaction through the ledger between these components, if the destination is inside the same canister, then we do it locally, so it doesn't go through the ledger. And this allows us to do a lot of transactions very quickly. So an overview, what we imagine is that the ICRC is a peer-to-peer protocol where different DAOs are going to govern their pylons and develop vectors and allow users to deploy them and connect them. And Neutrinite here is just helping in the creation of the protocol, but we are not orchestrating we're not collecting fees. So every DAO, every organization is invited to join us and work on the framework, on the protocol, and collaborate with us in this way. Also, additionally, while the pylons are always on the IC, the smart contract part, the tokens may be in different blockchains. In this case, they can be in Bitcoin or Ethereum, and also perhaps using vectorized Uniswap, something like that. On the IC part, we have the IC ledgers, chain fusion tokens. And also, when we add in the builder a component which is from another pylon and connect it, it shows here with yellow, which means that now it's a real ledger transfer. And this is how it looks at the end. We have local transfers, which are very fast. And when components communicate with other vectors on different pylons, they're going through the ledger.
Thank you very much. That was quite some visualizations that you had there. Thanks for sharing the vision also. All right, this is the end of today's Global R&D. Thanks for joining us. This will be recorded and shared, so you can find the recording in YouTube later. And do join us next month, end of October, when we'll share with you more exciting news about ICP. Thank you very much.